Hey guys, welcome to your second video of Flip Classroom. Today we are going to continue with rate of change any which way. The only difference today is we are going to start with different things. They could give you a verbal description, an equation, a table, or a graph. So what I need you to do before we get started is to go ahead and grab the multiple representations any which way document sheet and get ready to take some notes. First example says, use the information from the scenario to complete the table, graph, and equation that represent the rate of change. This is nothing new for us. We've been doing multiple representations all year. So, the verbal scenario says, Sarah and her dog Sam walk at a rate of 2 miles per hour on their evening walk. So, you need to think to yourself, what's important in this scenario? This per is important. That tells you that this 2 is your coefficient, or your rate of change. So, what is our independent variable? Would it be miles or would it be hours? If you said hours, you would be correct, and that means miles would be your dependent variable. So, in 1 hour, Sarah walks 2 miles. In 2 hours, Sarah walks 4 miles. In 3 hours, she walks 4 hours, she walks 8. And that means X goes here and Y goes here. So before we can start, we need to go ahead and figure out our process. How do you get from 1 to 2? If you remember, I told you to always start with multiplication. How do you get from 1 to 2? You multiply by 2. Once you figure that out, see if it works for the whole table. 2 times 2 does equal 4. 4 times 2 equals 8. So our process is 2 times 1, 2 times 2, 2 times 3, 2 times 4, and that would make 2x. So with just the information from the table, we can go ahead and write our equation. Y equals 2x. Easy. So now we take the information from the table and we graph it. Remember, x is your x-axis, and then you do your y's. So we walk to 1 and jump to 2. Walk to 2, jump to 4, 3, 6, 4, 8. And because it's multiplicative, we know it starts where? If you said the origin, you are correct. So there's your graph. You ready for another example? Here we go. But before we do another example, we need to think. There's a few more things we need to think about. We know that our equation is y equals 2x. So how many miles will Sarah and Sam travel if they walk for 1.5 hours? This 1.5 with the hours we know is our x. So y equals 2 times 1.5. If you can't do that in your head, get your calculator. So y would equal 3 miles. Let's look at B. How long will it take to walk 5 miles? Well, now we're given miles, so we know that that equals your y. So 5 equals 2x. The most important thing to think about with these is your labels, and you got to remember where your labels were with your table. If you go back to the, you know that hours are going to be where your x's are and miles are where your y is. So now all you have to do is solve for x. Divide both sides by 2 because we're trying to get rid of that coefficient in front of x. So x equals 2.5 or 2.5. Last question. If Sarah and Sam can walk at most 14 miles in a week, how many hours have they walked? All you have to do, 14 miles. So 14 equals 2x. Divide by 2, x equals 7. And at most is going to tell you you're not using an equal sign, but you are using what? Less than or equal to. Alright, next example. The table below shows how much weight Anna has lost. Use the information from the table to complete the graph scenario, an equation that represents the rate of change. So, how do we get, well, let's do verbal first. We know that Anna loses 1.5 pounds per what? Per week. And we get that from the table, weeks and pounds. So now let's talk about our process. How do we get from 1 to 1.5? Remember, always start with multiplication. 1 times 1.5 would get you to 1.5, but we got to make sure it works all the way down. 2 times 1.5 is 3, it works. 3 times 1.5 is 4.5, so we can assume that it works. So 1.5 times 1, 1.5 times 2, 1.5 times 3, 1.5 times 4, and 1.5 times 5. And they work all the way down. Now we could put an x here and a y here, and we can come up with our equation. 1.5 times x. So now that we have our equation, we can come down here. Y equals 1.5x. And now can we go ahead and graph it? Yes, we know that it is a multiplicative relationship, so we know it starts at the origin. So then we walk up to 1 and jump to 1.5 and put a dot. Walk to 2 and jump up to 3. Walk to 3, jump up to 4.5, and so on, and that's what your graph's going to look like. So now that we know our multiple representations, let's answer some questions. Y equals 1.5x. Notice that I brought that equation with us so we could use it to help us with these questions. How much weight will Anna lose in 8 weeks? Well, go back up and find out where weeks is. Weeks is your x, so you know you're solving for x. Or that's where you're plugging in 8. I apologize. It says 8 weeks, and we know weeks equals x. So y equals 1.5 times 8. If you can't do that off the top of your head, come over here. 1.5 and 8. Unless you have a calculator, that's fine. Our answer is 12 pounds. Y equals 12 pounds. So let's go to the next question. How long will it take Anna to lose 15 pounds? Pounds we know is going to be your y. So 15 equals 1.5x. We know we need x by itself, so we divide both sides by 1.5. And if you can't do that, come over here. 15 divided by 1.5. You know you have to move that decimal, and that means you have to add a 0 there. 15 going to 15 one time. That's 15. Zero, bring down that 0. You're not done. 15 going to 0, 0 times. So how long will it take her? 10 weeks. And last question. How long will it take Anna to lose more than 18 pounds? So we know pounds is y, so greater than 18. More than we know is greater than. And we have 1.5x. Well, solve it just like an equation. 1.5 divided by 1.5. Use your calculator if you need to, or do your long division over here. Move that decimal, which means you add a 0. 15 going to 18 one time. That's 15. How many times can 15 go into 30? It'll take her 12 weeks. Do you see how you can use information from an equation, a table, or a graph, and you can answer questions based on it? That's the point of tonight's lesson. So let's do another example. Use the information from the equation to complete the table, graph, and verbal description that represent the rate of change. We talked about on Friday and on Monday that the coefficient right here is your rate of change. So it says the equation has a rate of change of 1/2. Once you figure that out, you can come up here and come up with some random x's. Remember I said you need to make sure you have a negative, a 0, and 2 positives. And then you know the process is right here is 1/2 x. So 1/2 times -1 would be -1/2. 1/2 times 0 is 0. That's where you know it's multiplicative, because it has a 0 for an x and a 0 for a y, and you know it starts at the origin. 1/2 sorry guys, hold on. 1/2 times 1 is 1, and 1/2 times 2 is 2, and then you have your x here and a y, so you have 1/2 x. Once you have your table, you can go to your graph. You have -1/2, I'm sorry, you have -1, and then you go down to -1/2, put a dot. Then you have your origin, 1, and then go up to 1. I lied to y'all, that's 1/2, sorry guys. 2 would be 1. So there's your graph, that's what your graph looks like. So now we can answer some questions based on this information. What is the value of y if the value of x is 20? Well, it tells you what x is, so what are you plugging in? Y equals 1/2 x. So equals 1/2 times 20. Well, what is half of 20? Y equals 10. Then find the value of x as y is equal to 17. Well, 17 equals 1/2 x. You know you need to get rid of that 1/2, so you multiply by the reciprocal, 2 over 1. If you do it on that side, you have to do it to this side. And then you put a 1 under that 17 to make it a fraction. Those cancel, so you're left with x. 2 times 17 is 34, and 1 times 1, so your answer is 34. And then lastly, for what value of x is the expression 1/2 x less than 31? So less than 31, 1/2 x. Again, multiply by the reciprocal. You have 62, and those cancel, is less than x. So there's your answer. Ready for another example? So use the information from the graph to complete the table, equation, and verbal description. So now we're given the graph, and we're given lots of points. So we're going to start with this one. -3, 9. Then we have -2, 6, 0, 0. And then we have 1, -3. And we have 2, -6. Alright, so find the rate of change. How do you get from 9 to 6? You minus 3. 0 to -3 is -3. -3 to -6 is -3. -3 to -2 is +1. -2 to 0 is +2. 0 to 1 is +1. And 1 to 2 is +1. So your rate of change is -3 over 1 equals -3. So as the value of y increases by 1, the value of x decreases by -3. So our equation, or we got to figure out our process. How do we get from -3 to 9? -3 times -3. -3 times -2. -3 times 0. -3 times 1. -3 times 2. So our equation can be y equals